Okay, from the last video, we kind of explained, again, the goal of that video was to explain why plate tectonics move. And it is necessary that we discuss how the plate tectonic theory was developed from continental drift, from seafloor spreading, from this concept of convection currents in the mantle, and the internal structure of the Earth, right? But it's kind of like it did not answer directly what plate tectonics theory, the modern version, actually says about why the plates move. Okay, so this is the goal for this video, to explain why the plate tectonics move according to the plate tectonic theory itself. Um, so if we look at this, our activity, our asynchronous activity 4, the last time, for week 7, I think. Um, there's an explanation there. So recall that during the start of the development, scientists thought that it's the upward movement of magma in ocean ridges that causes the seafloor to spread. So you have these two plates. When magma comes out because of convection currents, the upward movement simply parts the two segments sidewards. Okay. While that is true, there's actually other explanations for that according to the tectonic plate theory, now that we have a lot of data for it. So, the first one mentioned, that is called a ridge push. Okay, this is caused by the upward motion of magma in convection currents directly below ocean ridges. As magma moves up through the ridge, it pushes the plates to move toward the side. Again, this is the same explanation as what was offered to us by the seafloor spreading theory. Magma comes out, it pushes the two plates to move sideways. Okay? However, now that we know a lot of things, we now have other explanations, like, for example, mantle drag. So, mantle drag is the sidewide motion of convection currents underneath a plate. As asthenospheric materials move sideways in the mantle, the lithosphere above it is dragged also. So, here, if ridge push is because this moves to the cracks, pushing the two to move sidewards. Mantle drag is really, remember, convection currents move up and then they move sidewards and then go back down, creating the cycle. So this one is really about the sideward motion of the convecting current. So as it moves up, there is a ridge push mechanism created, but as the magma or convection current circulates and moves sidewards, it drags the whole thing. And again, kind of like ocean and boat. If the ocean has current in it and the current is moving towards this direction, the boat on top of it obviously will be dragged along. So that is mantle drag, movement of uh, asthenospheric material sidewards that drags the lithosphere above it to move sidewards also. And then lastly, we have this concept of slab pull. Slab pull is the force created because of the weight of the subducting edge in convection and subduction zones. So for example, here you have these plate subducting, but this part is heavy. So if it's heavy, it pulls this whole thing downwards, not related to the convection currents here. It's simply related to the weight of this one. Okay. Now, to give you a more vivid example for that, I have here a video from Minute Physics, one of my Minute Earth Day, one of my favorite channels in YouTube, Minute Earth and Minute Physics. So this is a demonstration. I will just mute this. So you have a chain and it's dangling towards the side. So obviously, because of gravity, this would fall. But notice what happens. Just simply because of the weight of that dangling part, it actually pulls the whole chain downwards. So that is what we call slab pull. Okay. So now, what does the plate tectonic theory say about why the tectonic plates move? It's because of these three mechanisms. Ridge push, when magma comes out of the ridges, therefore parting the two plates sidewards. And then you have mantle drag, that means the sideward movement of the convecting current. It's like a boat floating on the ocean floor, the ocean water, when the ocean water has current in it. So the boat gets dragged. That's called mantle drag. And then slab pull, it's simply because the subducting head, or the edge of the plate that is subducting is quite heavy, and because of gravity, it drags down the whole slab, so to speak. So it pulls down the whole slab. So slab pull. So again, there are three mechanisms according to the modern plate tectonic theory: ridge push, mantle drag, and slab pull. Okay?